today we have an integral that we're going to use Feynman's method of integration for, and that's the integral from 0 to infinity of e to the minus x sine x over x. So we're going to let a function f of t be the integral from 0 to infinity of e to the minus tx sine of x over x dx. Now, first we want to see what f of infinity is. So f of infinity is going to be, so we want to plug infinity in for t, e to the negative infinity is 0, so this is just going to be the integral from 0 to infinity of 0, which is just 0. Now we also want to know what f of 1 is, so f of 1 is the integral from 0 to infinity of e to the minus 1x sine x over x, which we'll see is just our integral I. So f of 1 is I. Now we're going to take the derivative of both sides of our function f of t, and that gives us f prime of t equals the derivative with respect to t of the integral from 0 to infinity of e to the minus tx sine x over x dx. Now we can use a Leibniz rule for integration, and we can interchange this derivative and integral sign if we replace the derivative with a partial derivative. So this becomes the integral from 0 to infinity of the partial derivative with respect to t of e to the minus tx sine x over x with respect to x. So as this is a partial derivative, we treat everything else as just a constant except our functions of t. So when we take the derivative of this e to the minus tx, this is then going to give us the integral from 0 to infinity of minus x e to the minus tx sine x over x dx. Now obviously the x's will cancel out, so this just becomes minus the integral from 0 to infinity of e to the minus tx sine x with respect to x. And now we're going to let this be a new integral called j, and then I'm going to clear some space so we can solve that. So now we need to solve this integral, and first I'm going to let j equal this integral without the limits, so e to the minus tx sine x dx, and we're going to solve this using integration by parts. So u equals e to the minus tx, du by dx equals minus t e to the minus tx, dv by dx is sine x, and that means v is minus cos x. So that means j is just the same as uv, so minus cos x e to the minus tx, subtract the integral of v du by dx, so that's minus cos x times minus t e to the minus tx with respect to x, and so these two negatives will cancel out. So now we have another integral, and we're going to use parts again, and we're going to say u equals t e to the minus tx, so du by dx is minus t squared e to the minus tx, dv by dx is cos x, and so v is sine x. So that means j equals minus cos x e to the minus tx for this, minus, using integration by parts on this integral, we have t sine x e to the minus tx, subtract the integral of sine x times minus t squared e to the minus tx with respect to x. Now if we expand this bracket, we get minus cos x e to the minus tx minus t sine x e to the minus tx, and then we can take this minus t squared out, and so that in total gives us minus t squared, and when we take this out we see that this integral is the same as our original integral, which was j. So we can say minus t squared times j. So now we know that j equals all of this minus t squared j. So if we move the t squared j to the other side and then divide by 1 plus t squared, we get that j equals cos x e to the minus tx minus t sine x e to the minus tx over t squared plus 1. So now I'll clear some space again. So now we've worked out what j is, we just want to work out what f prime of t is, which is just going to be this bounded from 0 to infinity. So when we plug infinity into here, we get e to the minus infinity cos of infinity minus t sine of infinity over 1 plus t squared. Now, cos and sine are values between 1 and minus 1, which means this has to be a finite value, assuming t is a finite value. As e to the minus infinity is 0, 0 times any finite value is just 0. So in total that will be 0. Now when we substitute in 0, we get e to the 0 cos of 0 minus t sine of 0 all over 1 plus t squared. Now sine of 0 is 0, cos of 0 and e to the 0 are 1, so this becomes 1 over 1 plus t squared. Now we have that f prime of t equals 0 minus 1 over 1 plus t squared, which is just minus 1 over 1 plus t squared. So if we now integrate both sides from 1 to infinity, we use the fundamental theorem of calculus to show that this is the same as f of infinity minus f of 1. And on this side, we know that the integral of 1 over 1 plus t squared is arctan of t. So this is going to be minus arctan of t from 1 to infinity. Now, we worked out earlier what f of infinity and f of 1 are. So we know that 0 minus the original integral we wanted to work out, I, is the same as minus arctan of infinity plus arctan of 1. Now if we take the principal values of these, we see that minus I equals minus pi over 2 plus pi over 4, giving us that I equals pi over 4. And we're done. That's all for this video, thanks for watching. If you have any questions or video suggestions, leave them in the comments below, and if you want to see more content like this, subscribe now.